Hello. Our objective today is to explore a little bit about the notations related to functions, their inverses, and their derivatives. So particularly we want to look at the difference between f inverse of x and f prime of x. Moreover, we want to understand how to talk about each of these types of things, inverses, functions, their derivatives. We need to talk about all this stuff in a context so we can understand what these notations are trying to say. So in this case, we need our variables to be defined. F of t represents the number of centimeters of rainfall that's fallen since midnight. T is the time in hours since midnight. So what does f of 10 equals 3.1 mean? The first thing I do is I make sure that I understand that I'm talking about hours since midnight as an independent variable and total rainfall as a dependent variable, so I can arrange them on the x and y axes respectively. I chose my scale based on the different numbers that I saw, and I saw the largest numbers were 10 and 16, so I wanted to make sure that both of those numbers were visible somewhere on my graph. In hindsight, I should have made this a bit more like counting up to 10 and using the whole graph. I could have seen better, because all my stuff was smooshed down at the bottom. But anyway, the first bit of information that I had was that f of 10 equals 3.1. And what does that mean? Well, that means that, 10 hours, that's by 10 a.m., 10 hours after midnight, 3.1 centimeters of rain had already fallen. So that shows up as a point on my graph that when x equals 10, y is going to equal 3.1. F inverse of 10 equals 16 hours. Notice that in an original function, I put in time, and the function tells me how much rainfall. For the inverse function, I put in the rainfall, and the function will tell me how long it would take, or would have taken for that amount of rain to fall. So this means that 10 centimeters of rain will have fallen by the time we get to 4 p.m. Now, how do I show this stuff on the graph? That's easy. Both of these points, we have the point 10 and 3.1, and we have the point 1610. Those 2 points are given definitely solutions to my function, even though I don't know the rest of the points. I can make some inferences from there. F prime of 8 equals 0.4 is not talking about rainfall. Instead, it's talking about a rate of change in rainfall. So basically what it's saying is we have a rate of 0.4 centimeters per hour, or in other words, 4 centimeters every 10 hours of rain. That's how fast the rain was falling at 8 a.m. So I would say at 8 a.m., rainfall was accumulating at a rate of 0.4 centimeters per hour. Now, the most challenging, in my opinion, just to get your head around it, is the derivative of the inverse of a function. So the first thing I need to do is to make sure I understand my variables. If we're talking inverse, remember that the amount of rainfall is the independent, or is the given, the argument, and then the time represents the dependent variable. So it's inverted from the original given function, which means 5 is actually specifically referring to 5 centimeters. So one thing I know is we're going to be somewhere at 5 centimeters. The other thing I know is we had 3.1 centimeters at 10 a.m. and at 4 p.m. we had 10 centimeters, so 5 should exist somewhere between 10 a.m. and 4 p.m. Now where you put it, it's up to you. I just picked a place that looked like it naturally flowed with the rest of the points I had on the graph. But specifically what I want to do is I want to show how the rate of change is 0.4. So I don't really know when we had that change of 0.4, but I just can kind of put it in the graph somewhere. But the interpretation says when the rainfall reached 5 centimeters, the rainfall was at 2 hours per centimeter as a rate. So 2 hours per centimeter is kind of confusing, so I reciprocated to get a half a centimeter per hour. So that's what's really tricky about plotting it, because again, we're talking about an inverse value. An inverse usually has an inverted graph to go with it, but we're going to re-invert and put this stuff back into context of just the rainfall over time. So if this statement is true, that f prime of 5, if inverse prime of 5 is 2, then I also know what's true is that 1 over f prime, inverse of 5 is equal to the derivative f prime of 5. Or no, not 5, but f prime of x. I guess I shouldn't have wrote that down because now I'm backtracking on it. But the point is, if we were growing at a rate of 2 hours per centimeter, then converting into my function, I would change that to a rate of 1/2 centimeter per hour. Alright, So I hope that's helpful to you. What I want to point out is, again, to be able to take this simple, clean, elegant notation and unpack it to actually state what it actually is trying to tell us in context, and to be able to visualize what that must mean. Realize, again, that what we have to do is make sure we're clear about independent and dependent variables, and that we understand the concept of inverse, swapping the variables, and finally that we understand that sometimes we'd be given a rate if we're given a derivative, and other times we'll be given an actual position. That's if we get a point. So keep all that stuff straight and you'll be fine. Thanks for watching.